Good afternoon, everyone. Hope all is well. Hope everyone's doing all right. Giving everybody a chance to get connected, and then we'll get started.
Good afternoon.
Good afternoon. Good afternoon. All right. Looks like pretty much everybody is connected. So once again, good afternoon. Hope everybody's doing all right. Hope everybody's doing great. We're going to talk about a little bit of things, a few topics, few light topics out of chapter 3. Um, but we're not going to do too much because we got chapter 1 and chapter 2 out there. But when it comes to the summer, we don't really have the luxury of not doing anything. We got to squeeze 10 weeks into 16 or 16 into 10 weeks. So got to make use of our time. So we'll do a little bit in chapter 3 and then call it a day and make sure we're all clear on what you guys what's expected of you as well going forward. So you can write this title down for 3.1 summaries for symmetric distributions. Then I'm gonna go to another page where I have all the stuff already written down. So just write down the title, give you a chance to do that, and then like I said, I'll switch to another page. All right, so of course you guys aren't looking at this title. Your title is different, but we're starting with mean. Your mean is another word for the average. In statistics, we call the average the mean. But the same way you would find your average, the same way you find the mean, you add up all your data values, divide by the number of values. Let me see if I can get this. Now I'm gonna give you room for this green statement over here. Notice I got 155. That's a statement that's asked in Math Lab. So I just want to make sure you see that. So it is located at the balancing point of a distribution of data. And I'll slide it over for the other green statement in a second. We're just giving everybody a chance to write what we have up. And so in red, you see we have an example, just a light example of a data set. If our data set is 1, 2, 3, 4, 5, we would add those values together, which is 15. We have 5 numbers, so we divide it by 5, and that'll be 3. So your average or your mean would be 3. All right. And so that second statement in green, it is one representation of the typical value of a variable. All right, anybody still copying? Can I scroll up? Okay.
So I just wanted to let you know I am here in class, but I'm at work. And of course, there decided to be a 30 group Navy retirement party come in. So I'm still here. I don't want you to think that I'm not here.
Okay.
I have to listen in every couple of minutes because the girl that was supposed to work today called in and they were like, hey, yeah, you can come in, right? I was like, cool. So, but I am here.
Okay, not a problem. Thanks for letting me know. All right, so our next one. So now for your section, your book, I believe median is going to be in another section. I think it might be 3, 4, something like that. Anyway, but it's okay to just talk about it now since it's in the flow of mean, mode, and median and stuff like that. So just let you know, it may not show up in this section, but it will show up in the next section or two. So it's still in the same chapter though, but let's go ahead and knock it out while it's in that flow. So median, make sure, can everybody hear me okay? I see some said about my unstable connection. Everybody okay? Can y'all hear me? Can somebody type in the chat yes or unmute, say yes? Oh, okay, cool. I just want to make sure. All right, thanks. Just want to make sure. All right, so median. List your data values from least to greatest. So don't forget that a lot of times people forget that first step. And then from there, of course, all your answers are going to be wrong because you have to list your data values from least to greatest. Now, step 2 and 3 aren't necessarily two different steps. They're two different scenarios. So if your number of data values is odd, then you're going to take the middle value. If the number of data values is even, then you take the mean of the two middle values. So I'll show you what that means in a second. I'll just give you a chance to write down what's in black. All right. So let's look at two different data sets, one with an odd number of data values, one with the even number of data values. All right, so if the data set is 1, 2, 3, 4, 5, I have 5 numbers. You see in the blue, odd number of data values. So that means I have a legit middle number, which is just 3. And that's what my median is. All you do is pick out the middle number. Your median will always be your middle number, or it's the data value that splits your data set into half. So your middle number would do for you. So now if you have an even number of data values, like the second data set is 1, 2, 3, 4, 5, 6. So we don't have a legit middle number. So what we do is take the two middle numbers, which is 3 and 4, or which are 3 and 4, add them together and divide by 2. And that'll be 3.5. And you notice 3.5 fits right in the middle of the data set, splitting it in half. So once again, if it's odd, you actually take your middle number. If it's even, you're going to take the two middle numbers, add them together, and divide by 2.
Will it always be divided by 2?
Yes. Mm-hmm. Hold on 1 second. Sorry about that. Scrolling up on black. Everybody done with the black? All right. So last two statements in green says the median separates the data set into halves. I mentioned that. And then it also represents a typical value in a data set. So you just have these different ways of expressing your data that represent the typical value of your data set. We talked about a mean at first. Now we're looking at the median. All right, any questions, any problems before we go to mode?
Yes, I'm still writing.
Okay, not a problem. I'll pause right here.
Okay.
Yes, so somebody asked in the chat, one of your classmates asked in the chat about the first test. Yes, you can take it on your own time. It is not proctored. So, yep, as soon as you're ready to take it, it is available for you to knock out. Mhm. I most definitely, whenever we're going to proctor a test or proctor anything, I most definitely will give you information on that. Yeah, no problem. And then give you like a list of how we're going to operate on that day. So how do we do our assignments? Yeah, did you come the first day when we went through math lab? Okay, so I'll show you. You can stay back after class because really you go into math lab and you just do your assignments through math lab. I don't know if that's what you're asking or not, but like I said, we can stay back a few minutes after class, make sure you have clarity. Okay. Oh, now definitions, you would just write. You can either just write them in your notebook, take a picture with a phone or whatever the case may be, scan it, and then email it to me. Or if you just want to type them up in a Word document and then send it to me, it's up to you how you want to do that. Yeah, you can save it into Word. It's just really up to you. Some people like to write stuff in their notebook, so they took pictures of it and sent it to me with their phone, stuff like that. Or like I said, you can do it in Word. That's fine. All right, everybody done with this one before I scroll up the mode? Okay, let's see. Just email it to me. Yeah, email it to me, and then I will shoot you an email back telling you I got it. Some people have done that already, so I'm gonna send an email to you. As just a confirmation of receipt. I'll send it to you soon. But I have seen the emails for those who have sent their definitions already. Okay, not a problem. So mode, think about most. The data value that appears the most frequently will be your mode. It is possible not to have a mode. It is possible to have more than one mode, depending on if you have a large data set, a large enough data set. Bimodal means you have two modes. Multimodal means you have more than two modes. All right, scrolling up. So just an example of a data set here. If our data set is 12789675297651347, our mode would be 7 because 7 appears the most times. Any questions, any problems? All right, a summary of data is said to be resistant. And I believe we're going to talk about this more so when we get into median, but we'll go ahead and talk about it now. Because remember I said median comes up in another section. I believe this comes up when we talk about the median section. But since we're here, let's go ahead and knock it out. You already have the information. So a summary of data is said to be resistant if outliers, in other words, very extreme values, to the data set do not affect it. So outliers are very extreme values, can be very, very small or very, very large compared to your data set. They do not affect your data or the summary of data if it is resistant. Anybody holding on to the red up here? All right. Get a chance to write that down before I go into the example. All right. So looking at the first data set, we've already actually went through, if our data set was 1, 2, 3, 4, 5, what our mean would be and what our median would be. Our mean would be 3. That's when you add up data values, divide by 5. That would be 3. And then our middle value would be 3 as well. All right. So we already walked through that. So now if we change the data set and make it 1, 2, 3, 4, 500. So 500 will be considered an outlier compared to the rest of the data. You got 1, 2, 3, 4, then you have 500, a very extreme value. Now, if I were to add those data values and divide by the number of data values that I have, that would end up giving me 102. So notice my mean did change. But if I were to take the median is still 3, because remember, your median is just your middle value. So this means that the median is going to be resistant or considered resistant to outliers. Outliers do not affect your median. Other things may affect it, but not outliers. So green statement, last statement for this section, it is a good choice for a measure of center if the data contains outliers. Talking about the median. All right, anybody holding on to anything before I go to another page? All right.
Can you explain that sentence a little?
Let me go back. Which sentence?
The green one.
Oh, it's just a good, if you want to explain your data, if you want to be able to compare your data to another set of data and you have outliers, it's better to use your median than it is to use the mean. So it's just talking about if you have outliers, it's better to use your median if you want something that best explains what type of values you have in your data versus using the mean, because if you use the mean, the outlier is going to take it someplace very extreme and it's not going to fully explain what's going on in your data set.
Got it. Thanks.
Yeah, no problem. No problem. All right, anything else? Anybody else before I go to the next page? All right, all right. Okay, not done with 3.1. We're gonna look at standard deviation and variance. I just wanted to make sure I didn't go too far. So let me see here. All right, so standard deviation and variance. So your standard deviation, somebody saying something? Was somebody unmuting? Okay, cool.
It's still 3. There's less than 3.1 still.
You said still 3.1.
Yeah.
Mm-hmm. Yep. So standard deviation measures how far a data value is from the mean. And your variance is the standard deviation squared. And it's just another way to measure the spread of data. All right. Anybody who knows standard deviation?
Yes.
Yes. Okay. Not a problem.
Okay.
All right. Thank you. Okay. Yeah. No problem. No problem. Someone's saying something to me in the chat, y'all. But yeah. Okay. Standard deviation. We already talked about a variance. So while you guys copying this, so I'm not going to hold you responsible for knowing how to do the variance or standard deviation by hand. But what you are held responsible for is finding something reliable that will do it for you. So whether it's app, calculator, website, or something along those lines that will calculate the standard deviation or variance. So calculating standard deviation and variance isn't really a hard process, but can be tedious. And it's one of those things where if you mess up on one number, it will mess up all of your calculations. So once you go past 20 numbers, it can be a little, I won't say problematic, but it can be a little tedious, like I mentioned. If it was different type of course, let's say if all you were math majors, then maybe I would hold you to that. But you guys aren't held responsible for that. You just need something reliable. I'm going to show you an example of that. So we have easycalculation.com. I'll show you that one. You can use that one if you want. You don't have to. You may want to download something into your phone. I'm not asking you to pay for anything else. So I'm talking about free stuff. Now, if you decide to buy something, buy a calculator or pay for an app, then that's free. That's fine. That's on you. But what I'm asking for, there are a bunch of free things out there that can calculate these things for you. And I'll show you that in a second, just giving you guys a chance to write down everything. All right, can we scroll up? You can write down that example right there, and then we'll go to easycalculation.com. So just the data set 62, 88, 77, and 68. And standard deviation is 11.3, variance 127.69. All right, can I go to the next page? Everybody okay? All right, so,
Are you gonna show us how you got that number?
well, I'm about to do it now.
Okay.
Let me get to my share screen. All right, so standard deviation, easy calculation in Google. And this is the first one right there. So if you don't want to use easycalculation.com, like I said, that's fine. But you can Google standard deviation calculation and see what other websites pop up. Or like I said, if you want to download an app from, the App Store or whatever, that's there for you to do as well. So here, just make sure you pay attention to whatever directions they tell you. So in this case, they tell us to type it in, use commas to separate our numbers. I've seen where it says separate by space. Some say separate by semicolon. It just depends on what your website or app is telling you to do. So we have 68. Let me go back. 88, 77, 68. What, 268s? 62. So 68, 77, 62, and 88. And just hit calculate. And there goes those numbers. All right. So notice this one actually gives you the mean, which is the average. This is standard deviation and variance. Notice here it says population, standard deviation, and variance, population variance. So let's see. So it doesn't matter what order. No, typing in, no, the order doesn't matter. You just got to make sure you type in the right numbers. Yep. So notice how one of them says just standard deviation, the other one says population. So these two are based on the population. These two are based on your sample. So when you get into your definitions, there should have been one that is fine. What is the population? What is the sample? So basically, population versus sample are exactly what they sound like they are. The population would be the bigger body of, let's say, data. Then a sample would be a group or a subset of that. So a good example of that is let's say TCC student population is the student body is the population. This class is a sample of the TCC student body. So when it comes to population versus sample, the formula is a little different for the standard deviation and variance. So it's just slightly different. So that's why you get different numbers. So it does matter whether you're dealing with the population versus the sample. And whatever you're dealing with as far as math lab is concerned, we'll let you know. Just like for this example, it doesn't say it, but if you only have 4 values, we had 68, 62, 77, 88. Well, then more than likely that's the sample, not the population. So but your app or website or whatever the case may be, calculator should be able to distinguish between the two and calculate that for you. So questions on what we did just there, what you're responsible for. So once again, hopefully everybody hear me. Unfortunately, every now and then you get one person and be like, yeah, man, I was trying to do it, blah, blah, blah. We know I didn't see any notes for it. Okay, so there's no notes on how to calculate standard deviation and variance because I'm not holding you to doing that on your own by hand. Once again, we want to use technology because that's what you would do in the real world anyway. You would use some form of technology to calculate standard deviation and variance. All right, any questions on that? All right, let me get back to it. So 155. So what I'm going to do is hold on and pause right there. I think that's a good place to stop. Let me do this and give you these notations. Let's go into notation. We'll do notation and then we'll stop right there. Like I said, I don't want to throw too much at you, knowing that we got these definitions out there in chapter 1, chapter 2. But once again, I do want to do something because with summer school, it's kind of hard to not do anything on a day. So let's look at notation, and then after that, we'll close it out and send you guys out into the weekend. So notation, X is always going to represent your data value. All right. Somebody said something in chat. Okay, yeah, no problem. Greek letter mu kind of looks like a U with a longer stem. That's Greek letter mu. That represents your population mean. See what's going to happen in statistics. You're going to have certain symbols that hold true just for your population. Then you're going to have certain symbols that hold true just for your sample. And you'll know what you're dealing with depending on the symbols that you're using. And you don't have to see any words at all. You see Greek letter mu, you know you're dealing with population. And same thing with the other symbols that tell you that you're dealing with your sample. So lowercase sigma, Greek letter sigma, is your population standard deviation. Over here is capital sigma. Some of you may be more familiar with that versus the lowercase sigma, especially when it comes to fraternities and whatnot. But that represents the summation or the addition of, let's say, your data values. So that's what capital sigma represents in mathematics. But lowercase sigma is your population standard deviation. Lowercase sigma squared is your population variance. And then capital N is your population size. All right, so then your sample mean is X bar. Whenever you see a letter with the bar over it, that's that letter bar. So right here, I just give another example, that's Y bar. All right, and then lowercase s is your sample standard deviation. S squared is your sample variance, and then lowercase n is your sample size. So capital N will be your population size, lowercase n will be your sample size. All right, any questions? Any questions? So I believe, I still haven't checked yet, but I'll shoot you guys an email. I believe we're off on Monday for Memorial Day. So if that's the case, then, that's fine. What we'll probably do on next class, anybody still holding on to this? Anybody still holding on? Okay. So next class, we do 3-2 and 3-3. Well, 3-4 is relatively short. Yeah, so we probably, especially since we're missing on Monday, these sections are pretty short. So we might knock out all of them, but we'll see. We'll see. See how it goes and see how it flows. But I at least wanted to get one section out of the way as far as chapter 3 was concerned. What you guys are here responsible for up to this point is, we talked about chapter 1, chapter 2, and all we talked about today was 3.1. So that test is on chapter 1 and 2. And then you got your definitions. That's on chapter 1 and 2. So that's most definitely what you want to be working on this weekend. To the best of your ability. Now, if you got a lot of stuff going on, because it's a holiday weekend, it's fine. It's all about communication. If you can't get something done because you had stuff go down, then make sure you get with me on that. Do you recommend reading the chapters? I don't know about reading all of them because I pretty much went through the chapters and pulled out a lot of stuff that you pretty much gonna, I pretty much pulled out the stuff you're gonna need for the notes. And like when we go into when you get into it. So, you know, like when we get here, I'm pulling out stuff and I have statements, you know, like statements that, you know, of emphasis, point of emphasis that I, you know, and then we'll go to it. So not really. And then when you go to your definitions, like I pointed out, bulleted points, bulleted words. So, and then when you go to math lab going to point out certain things. So really, you don't have to necessarily read the chapters, but you should go there if you need, if there's a point of emphasis that you may think you have missed. And like if you're on a problem and it says, you know, it gives you the link to go to the textbook, then that would be a point when you would most definitely go to the textbook for. But I don't think you have to read the chapters. I just think you have to get into math lab and start looking at the points of emphasis that they give you and focus on those. So yeah. Let's see, any other questions? Yeah, questions? I know somebody had mentioned something about, is there unmuting? Somebody unmute? All right, guess not. So somebody mentioned about submitting your assignments. So this is once, this is 60. Let me see if I'm still logged in. No, give me 1 second. All right, nope, 245, we are 155. All right, so your definitions are right here. So you got 2 pages for chapter 1. Moving a little slow, 2 pages for chapter 2. And so you can write those down, then take a picture, send it to me, or you can type them in Word, send it to me as a documentation. I mean, as a doc, Word doc. Either way is fine, and just email them to me as far as those definitions are concerned. Now your assignments are right here, right above your definitions. Here go all your homework assignments. And then you see your first test has already been posted. You get 2 shots there. Oh, yeah, there you go. 2 shots there. All your homeworks are unlimited. Amount of tries to get the best grade possible. All right. So questions about your assignments. I know, like I said, somebody had asked about submitting your assignments. So everybody okay? You just click on it and then start answering the questions. All right. So everybody's good. Everybody's straight. Everybody know what they need to do. No problems, no questions, no concerns. Everybody all right? Okay. All right. So you say again now?
I said, thank you. Have a good weekend.
Oh, thanks. I appreciate it. You have a good weekend as well. I had talked over you, so I didn't hear you. So yeah, so you guys have a great weekend. Be safe. Have a great holiday. You know what you got to do. I'll see you next class. All right.
Thank you, Professor.
Thank you.
Thank you.
Thank you. You guys have a good one.
Thank you.
Thank you. Take care.